Alright, so in this video we're going to be talking about some of the emotional disorders that are really common and plaguing the United States right now, and actually the world. And then we're also going to be talking about regulatory and non-regulatory behaviors. So first off, I believe I'm going through some sinus stuff at the point that I record this video, so please excuse my voice. One of the most common emotional disorders in the United States is major depression. Depression is characterized by prolonged feelings of worthlessness and guilt, the disruption of normal eating habits, sleep disturbances, and a general slowing of behavior and frequent thoughts of suicide. So we've talked about depression before in this course in terms of various brain activation systems, but we're going to be talking about it just a little bit more here and delving into some of the aspects of depression that are associated with emotion control, and challenges regulating emotion. There is a genetic component to emotional disorders, in particular depression. So it does tend to run in families in the sense that if your parents are depressed or direct family members are depressed, then it increases your own chances of getting depression. But one factor that's hard to separate out is actually the environmental component, is that there is a genetic component, but it's also something that can be learned. So some of the habits or feelings that are associated with depression can actually be learned or passed from a parent to a child, in the sense that if a parent feels worthless and has trouble with guilt and has trouble with sleep, again, children will observe aspects of those behaviors and they can map onto them and start to have an increased likelihood of experiencing some themselves. So there is an actual genetic component, but there's also a learned environmental component as well. Depression is associated with a biological abnormality, so that there are differences in hormone release, again, elements of genetics, dysregulation in the amygdala, differences in size of the hippocampus that have also been linked with depression, but the real biological foundations within the brain are still being investigated. One of the key things that is understood is that early life stress can produce epigenetic changes in the prefrontal cortex. So early stress in life, and this can take various forms, this stress. The prefrontal cortex is the primary region of the brain that is involved in regulating emotions. And so if there are changes in the prefrontal cortex early in life, and particularly when the prefrontal cortex is developing, then that can result in sustaining changes or differences in epigenetic differences within the prefrontal cortex that could make emotion regulation in all of its forms more challenging and increase the likelihood of developing depression or other similar mood disorders such as bipolar disorder and anxiety disorders. And there's also a strong evidence so far that there is dysfunction of the amygdala or there are different connectivity patterns between the prefrontal cortex and the amygdala. Another common disorder are anxiety disorders. Generalized anxiety disorder is persistent high levels of anxiety, often accompanied by maladaptive behaviors to reduce that anxiety, and it's thought to primarily be caused by chronic stress. And so this is where normal stress over time can really get out of hand. And one of the things that I want to make clear when talking about emotional disorders, such as depression and generalized anxiety disorder, is that everyone gets anxious and depressed sometimes, but in order for depression to qualify for major depressive disorder or anxiety to qualify for a particular anxiety disorder, then that anxiety or depression needs to be debilitating and have a significant negative impact on the individual's life. A phobia is a type of anxiety that's more specific. It's clearly defined in regards to an object or a greatly feared situation. And then we also have panic disorder. This is when you can have recurrent attacks of intense terror that come on without warning and without apparent relation to external circumstances. Panic disorder is more likely in generalized anxiety disorder or PTSD. It's more comorbid. You can have generalized anxiety disorder or PTSD or depression without panic attacks, but having a panic attack or panic disorder is more likely when you have major depressive disorder generalized anxiety disorder, or post-traumatic stress disorder. And now, since a lot of these disorders, particularly anxiety disorders, can occur with regards to fears, a lot of research focusing on anxiety and post-traumatic stress disorder has investigated whether you can actually try to erase some of these fears. And so there is some research that suggests, yes, you can.
In everyday life, we have all sorts of fears, and my personal experience with fear is parachuting. I did it several times, and I discovered it's very scary. But then I got interested in how you overcome fear. And my line of experiments deals exactly with that: how we overcome fear, how we change fear. And the particular experiment we just published now in Nature is about preventing fear altogether, preventing it from returning.
In this experiment, we studied a very simple type of fear learning where we present you with a neutral stimulus like a yellow square, and we pair it with a shock. After a few pairings, your body elicits a fear response. We measure this by measuring the skin conductance response.
Okay, that was enough. And you can see the response on the computer. That's a very strong response.
It's really just the electrical conductivity of your sweat glands, and that's just part of the natural arousal response you would have with fear. What we can do, though, we can get rid of that fear now just by presenting the yellow square over and over and over again and have nothing bad happen. Eventually, you're going to learn that the yellow square doesn't predict shock, and I'm not going to see this fear response in your body. So this is called extinction. And it works pretty well. It's the basis for treatments for phobias. The problem with that type of learning is that what we've done, and we know this from a lot of behavioral studies in humans and other species, is we've created two memories. Yellow square predicts shock, and a second one, yellow square does not predict shock. And the problem is, over time, those two memories compete for expression. And this is one of the big challenges in treating anxiety disorders. We can get people in the clinic to not be so afraid of things, but now you get them out in a stressful situation, and all of a sudden those fears come back. It's the fact that we have two memory representations that are competing that leads this to happen.
So what we found in our experiment is that the way to get around the problem of fear coming back is to remind the fear memory before we do extinction training. So to remind the fearful memory, we just present the yellow square again. This brings back the fear. Then we wait a little bit, and then we start with extinction training, which is presenting the yellow square again and again. This manipulation keeps the memory extinguished. It prevents the fear memory from returning. So the reason why it works is because we take advantage of a phase of memory called reconsolidation. And this is a process that happens naturally whenever we remember something. A nice way to think about it is like a file on your computer. You have a file, a document you wrote, and it's stored. Then you open it, you update. You put in new information, then you save it and store it again. So now it's stored in a new form. It doesn't create a new file in addition to the old file. You have just one file, but now it's updated. So what we do is reactivate the memory. It goes into this phase called reconsolidation, which is basically the restorage of the memory. If we do extinction training at that time, it doesn't form a new memory. The information acquired through extinction is merged into the original memory, and it changes its original properties. So now we have one memory, but stored in a different form.
And now what we would expect is the case in that situation is when we wait a day, the fear doesn't come back. When we stress you, the fear doesn't come back. And that's exactly what we found. The big difference between this and what you see in the Eternal Sunshine of the Spotless Mind is here we're targeting a very specific fear memory, not your ability to recollect information. So in that movie, Jim Carrey wanted to completely forget Kate Winslet altogether. Here, because this specific type of fear memory, which is represented in your body's response to a fearful event, we're eliminating the memory of that. You will still be able to tell me what happened. And you will still, have all of that information available because that's another kind of memory we didn't target.
And that's a good thing because if you supposedly erase memories, you don't want to create blanks in your life that the whole parts are missing. If you still remember the content, you have continuity in your life. You just change your emotional response. So the intrusive emotional fear doesn't interrupt your everyday life whenever you remember. You can remember, but it's not stressful anymore.
So, at this point, how this works in the clinic is going to be all speculation. But what this data suggests might happen in the future is if you come into the clinic with a fear-related disorder like a phobia or PTSD, if we can understand how these memories are restored when they're retrieved, much as we did in this study, we then may be able to time our therapeutic interventions in such a way where we aren't creating new learning that's overriding those earlier memories, but actually rewriting them in a sense. If we can time that correctly so we can target these mechanisms, perhaps we'd have a more effective, long-lasting outcome.
So I hope you just like that video. I think it's a really, really, really well done study. And I have to admit that I'm also a little partial to it because I know both of the investigators that are featured. Dr. Daniela Schiller, I used to work with her at NYU. She was a postdoc while I was a graduate student. And then Liz Phelps, the lead investigator, she was actually my advisor during graduate school. Their expertise is fear conditioning, fear extinction, and learning the role of the amygdala in behavior. And so you can look them up to find out more about what they do.